Good morning, children. Today we will start with the next chapter, that is chapter number 9, Applications of Trigonometry. Now here also you are going to use the same concept of what you had done in the previous chapter. Okay? We are going to take the help of the trigonometric ratios for specific angles and try to solve the questions. In this chapter you are going to learn about finding the heights or the distances without actually measuring them. Okay, so here we are applying the trigonometric concepts in the real life situation. So whenever suppose we say that there is a building, this tall building is there, okay, and there is an observer, say at a particular distance from the bottom of that is the base of the building, there is a observer. You have to find the height of the building, or you may also be asked to find the distance between the observer, this is the observer, the point where the observer is standing, and this is the base of the tower. Either the question will be this way, that you have to find this particular distance, okay, or it may be asked to find this height of the building. These are the two type of questions which you can expect here. Now, when I say this is my observer, then with respect to the observer, the line which is parallel to the surface of the earth, that would be called as the horizontal line. Okay? This is the height of the building. This is the distance between the base of the building and the observer, and how the observer is observing the top of the building, this line will be called as the line of sight. Okay, it is called as the line of the sight. The angle between the line of the sight and the horizontal line, this particular angle, it is called as the angle of elevation. It is called as the angle of elevation. So these many things you have to note down here. Okay? This is the observer. Observer is standing at a particular distance, say D. Okay? From the base of the tower or the building. And this is the height of the building which you may be asked to find. Always try to locate the line of sight, horizontal line and the angle of elevation. Okay? Now suppose there is a building, okay? An observer is standing at the top of the building. There is an object like say a ball, okay? A ball is there. This observer is observing this ball, which is lying somewhere away from the building. Now what do you, if this is your observer, then this will be your horizontal line, okay? Horizontal line, it is always parallel to the surface of the earth, okay? And the observer is making a particular angle with the ground where the ball is, okay? So then this angle, that is the angle between the horizontal line, and this now becomes the line of sight, okay? So this angle will be now called as this is the angle of depression. This is called as the angle of depression. Now you know that this horizontal line is parallel to the surface of the earth. That means these are the two parallel lines. Now any angles which are formed between the two parallel lines, it will be congruent. Okay, so this particular angle which we call as the angle of depression, that will be equal to the angle which is formed by the line of sight with the earth. Okay, so now this will be also equal to the angle of depression, because we are asked to find the values with respect to a right angled triangle, isn't it? So this will be now become the angle of depression when the observer is somewhere top, and from there he is observing or she is observing any object on the earth, on the surface of the earth. Clear everyone? So these are the two things which you have to be careful with. Then we can go on and solve the questions. Okay? So you can just note down. Now let us take example 1. What does it say? A tower stands vertically on the ground, and from a point on the ground which is 15 meters away from the foot of the tower, angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. So there is a tower which is standing vertically on the ground. Okay. So let us draw a tower which is standing vertically on the ground. Just we will draw a tower. Okay. It stands vertically on the ground. This is the ground. And from the point on the ground, it is 15 meters away from the tower. So there is a point in the ground which is 15 meters away. So this is 15 meters away. Okay? And the angle of elevation of the top of the tower is found to be 60. So from this point, the angle of elevation to the top of the tower, it is found to be 60. Okay? So this is how the situation is. There is a tower. 15 meters away from the tower, there is a point, and from that point, the angle of elevation to the top of the tower is found to be 60. Okay? You are asked to find what is the height of the tower. So that's the question. So this is your question. What is the height of the tower? Now, height of the tower you can find because you have your one of the angle which is 60 degree. One of the sides also you are having. So let me name this becomes a right angle triangle. Let me name it as A, B, C. ठीक है? A, B, C triangle बन जाता है, right angle triangle है. Okay? You are asked to find the height which we have represented it by H. Now, if you want H, then which of the trigonometric ratios you should use so that you get H? You have the adjacent side to angle 60. And you want the opposite sides. So naturally either you use cot or you use tan. Okay. So let me take tan of 60 degree which is equal to H upon BC. BC we have, what is it? It is equal to 50. Also we know tan 60 value. Tan 60 value is root 3. So root 3 is equals to H upon 50. So therefore, H is equals to 15 root 3. So the height of the building comes out to be 15 root 3. Now again, you can more carry out the calculation, and 15 into 1.73 meters हो जाएगा. You calculate the value, okay? 15 into 1.73 you can calculate, putting the value of root 3. Follow? So this is how, this is just what we have done in the previous class, same thing only. Only thing you have to identify how you have the figure. Okay? Now, an electrician has to repair an electric fault of a pole of height 5 meters. She needs to reach a point 1.3 meter below the top of the pole to undertake a repair work. What would be the length of the ladder that she should use, which when inclined at an angle of 60 degree to the horizontal would enable to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? So first and foremost, understand that there is an electric pole, okay? There is an electric pole of this kind. Follow. And this electric pole, there is a fault on the pole, in this pole, and she needs to reach a point 1.3 meter below from the top of the pole. So this is the top of the pole. The electrician has to reach 1.3 meter below from the top of the pole. The whole pole it is 5 meter. ठीक है, और ये इतना जो है that is 1.3 meter and the fault has to be repaired at this position. ठीक है. Now what is the length of the ladder which has to be used so that ये तुम्हारा ग्राउंड लेवल है, ठीक है, और from the ground level an inclination of 60 degree has to be made to the with the ladder to this pole so that she can reach at this position. So there is an inclination of 60 degree. Okay, this doesn't look like a 60 degree. Can make it little more correct. Okay. So this is the point where the ladder is kept and it has to be inclined 60 degrees. Okay, and the fault has to be repaired at this position. Now this is also right angle triangle. Let me name this as A, B, C, and this point let me name it as D. Okay, you are asked to find the length of the ladder. You are asked to find the distance between the base of the tower and the base of the ladder. ये दोनों भी फाइंड करना है. So these are the things which are known to you. You can take the right angle triangle DBC. Can you see the triangle right angle triangle? So in triangle DBC. This is angle 60. Now you know that this whole length AB is 5 meter and AD is 1.3 meter. So can we have DB? Isn't it? So you know that AB is equal to AD plus DB. AB is equal to AD plus DB. Now AB value I know it is 5. Also I know AD value it is 1.3 plus DB. So DB is equal to 5 minus 1.3 which is equal to 10 minus 3 is 7 and 4 minus 1 is 3, that is 3.7 meter. So I have my DB value, that is this particular area length, it is 3.7. Okay, so ये मुझे मिला 3.7 meter. Now we have tan 60 ले लेते हैं क्योंकि हमें ये पार्ट चाहिए. पहले tan 60 ले लेते हैं. Tan 60 degree will be equal to with respect to 60 this becomes, that is DB becomes your opposite side and BC becomes your adjacent side, isn't it? So it is DB by BC. DB is 3.7. BC is unknown to us, but we know tan 60, that is root 3 is equals to 3.7 by BC. Therefore, BC is equal to 3.7 by root 3. ऐसे मिल गया मुझे. Okay. Now, BC I got it. That is the distance between the foot of the electric pole and the foot of the ladder that I have got. Now what is to be found? You have to find the length of the ladder. So length of ladder we can find out by taking sin 60. Okay, क्योंकि sin 60 क्या है? Opposite अपना sin 60 or cos 60, because now we have got the adjacent side also. The adjacent side is 3.7 by root 3. Okay, so when I take sin 60, I have opposite upon hypotenuse. opposite कितना है 3.7. Hypotenuse we do not know, we will take it as it is DC. Okay, so sin 60 value I know it is root 3 by 2 which is equal to 3.7 by DC. Okay, so that becomes DC is equal to 3.7 into 2 by root. So this is the value you should get for the length of the ladder. Clear now? Okay, so this is the real life situation where you can show this. Now coming to example 3. Okay. It is asked an observer 1.5 meter tall is 28.5 meter away from a chimney. So there is an observer. Let me draw the observer as an arrow. How much is his length or the height of the observer? It is 1.5 meter. Okay? And this observer is 28.5 meters away from a chimney. So there is a chimney here. Okay? And the angle of elevation of the top of the chimney from her eyes is 45 degree. What is the height of the chimney? Now here you should understand कि यहाँ पे observer का height दिया हुआ है. So the horizontal level should be this. Don't take it as this. This is the horizontal level, or from the eye of the observer it should be measured. And from the eye of the observer, you find that the inclination to the top of the chimney is 45 degrees. It is 45 degrees. Okay? You are asked to find the height of chimney. Height of chimney. You are asked to find the height of the chimney. So naturally we have so many things here, we can easily find out the height of the chimney. Let me take this as A, B, C, D, E. All the points we will mark a given A. So I have this figure. Now in triangle you are asked to find the height of the chimney. Okay, height of the chimney includes AB plus BE. Remember that. So in triangle ACB, we have tan 45 equal to opposite क्या है AB, adjacent क्या है BC. ठीक है, tan 45 का वैल्यू 1 है. हमारे पास AB है, AB नहीं है, so write AB as it is. BC क्या है? BC. It is same as 28.5. Okay, so it is 28.5. So you get your AB is equal to 28.5. That means this length I have got it as 28.5 meters. But I also know what is BE. BE is 1.5 meter, isn't it? So therefore, length of chimney is equal to AB plus BE. That is equal to 28.5. 28.5 plus 1.5. That is equal to 30 meter. Clear? So that is what is asked. You can easily find out. Only thing you have to get the figure properly. Now coming to the next question. That is example number 4. Example number 4. Example 4. What is given? That from a point P on the ground, the angle of elevation of the top of a 10 meter tall building is 30 degree. So there is a 10 meter tall building. This is the ground, and from a point P, the angle of elevation to the top of the building it is given as 30 degree. So this is 30 degree. But there is a flag on the top of that building. Okay, there is a flag on the top of the building, and from that point to the top of the flag. Okay, I just extend my flag so that I can get it properly. Okay, so this is how you have your flag, and this angle it is 45 degree. Follow? So the angle of elevation to the top of the flag, it is 45 degrees. Okay. Now you are asked to find the length of the flagstaff and the distance of the building from point P. तो point P से ये building का क्या distance है? Let me write it as Q. This is R and this is S. Let it be S. You are asked to find what is this length SR. Length of the flagstaff, that is what is asked. Now here again, you know that one more information will be given here. The building is 10 meter tall. The building is 10 meter tall. So naturally you should take triangle PQR, and you know that tan 30, triangle PQR matlab PQR. This is the angle. Okay, this is the angle. Okay, so tan 30 will be equal to what? RQ by PQ. RQ I am having with me, that is 10 meter. PQ I do not have. Once I get PQ, then I can use for tan 45. Okay, so tan 30 I know it is 1 by root 3, which is equal to 10 by PQ. So I have got my PQ is equals to 10 root 3, and root 3 value they have asked us to take it as 1.732. So that becomes 17.32 meter. This becomes 17.32 meter. Okay, so that is how, or we will just keep it as 10 root 3 only, because further also we will be having to find out. So we will keep it as 10 root 3. ठीक है, उतना ही रहने देते। हमें तो L का वैल्यू फाइंड करना, that is SR का वैल्यू फाइंड करना है। ठीक है, now in triangle PQS, what is it? Angle tan 30 ही ले लेंगे हम. Okay, but here angle is 45, so tan 45 degree. Tan 45 degree will be equal to SQ by PQ. Okay, SQ value we do not have, PQ value we are having with us. So let me take it as SQ only. Okay, and PQ value I am having 10 root 3. Now tan 45 का value 1 है, तो 1 is equals to SQ by 10 root 3. So SQ is equal to 10 root 3. So I have got this whole length SQ. बाद में इधर लिख रही हूँ. But SQ is equal to SR plus RQ. SR plus RQ. ठीक है? And we are supposed to find SR. So SQ minus RQ will give you your SR. SQ हमें मिला है 10 root 3 minus RQ value you are having 10, which is equal to SR. So SR will be equal to 10 into root 3 minus 1. Root 3 value it is 1.732 minus 1. So finally your answer should come out to be 7.32 meters. Calculation further you can do it. Okay. So this is how another example you can solve. Okay. See example 5. The shadow of a tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 degree than when it is 60 degree. Find the height of the tower. So suppose let me take this as the tower. ठीक है, और ये तुम्हारा ग्राउंड है. Okay. Now this tower, sun is suppose here. ठीक है, तो ये सन इस टावर का शैडो यहाँ गिरता है. ठीक है, so that shadow, this is the shadow. Okay, when we join the top of the tower and the shadow, this is your shadow. Okay, shadow of this tower when the angle is 60 degrees. When the angle is 60 degrees. Okay. Now, when the angle becomes 30 degree with the ground, the length of the shadow, it becomes 40 more than what was it earlier. मतलब अगर ये x था तो ये हो जाएगा x plus 40. Okay, so this much is 40. Okay, so अभी ये शैडो कितना हो गया? ये पूरा शैडो है ना ये वाले टावर का. जब एंगल with the ground it has become 30 degree. So this is full shadow. Here say here it is not shadow. But now the shadow, length of the shadow is 40 more than what was it earlier. Okay, so now length of the shadow, it is 40 plus x. Okay, what is this? This is the length of the shadow of the tower. Length of the shadow of the tower. Followed or not? Okay. Now what is asked? It is asked find the height of the tower. So this is the height of the tower which you are supposed to find. ठीक है, तो अभी you have to take let me take the names as A, B, C, A. ठीक है, first we will find what is tan 60 with respect to H and X. Okay, so I will rub out this line, then later on we can draw it. Okay, so let me. So what do I have? In triangle ABC. Okay, tan 60 degrees. It is equal to AB by BC, isn't it? Now tan 60 I know it is √3. AB value I know it is H, and BC value I know it is X. So this is the relation I have got. Okay. Now what do you do? In triangle ABD. In triangle ABD. What do I have? ABD. Whole triangle. Again, let me take, since the angle of elevation is 30, I take tan 30. Again, opposite is H upon the adjacent, that is, now it is BD. Okay, you can write it as AB by BD first, then AB is H and BD is 40 plus X. BD 40 plus X. देखो BD it is 40 plus X. So this is the length of the shadow of the tower when angle of elevation is 30 degree. Okay, so this is how you get. Now tan 30 value I know. How much is tan 30 value? It is 1 by root is equals to H by 40 plus X. Okay, so here H is equal to 40 plus X by √3. ऐसा मिल जाएगा मुझे, मैं ये इस तरफ ले लूंगी, H का वैल्यू ऐसा आ जाएगा, और इधर से मुझे क्या मिलता है? मिल जाता है, ठीक है। I bring it here, so it is √3 into √3x is equals to 40 plus x. So this becomes 3x. ये x को इस तरफ लिया, minus x will be equal to 40. So 2x is equal to 40. X is equal to 20. X is equal to 20. Got it? So x, once you get 20, then can we find h? We can find. Okay. So what do I have? H is equal to √3 into x, that is √3 into 20, that is equal to 1.73 into 20. Okay. So 3 2s are 6, 7 2s are 14, 2 1s are 2, 3. ठीक है? That is equal to 34.60. So you get your height of the building as 34.60. Okay, copy down.